Hello, let's try this question. Pause the video, try the question before looking at my solution. It's the best to study mathematics, alright? So look at this question. There are 60 students in the sixth form, right? 60 students in the sixth form. So, from sixth form of a certain school. Mathematics is studied by 27 of them, biology by 20, and 22 study neither mathematics or biology. Then you look at this question here. So you can choose a method to helping you solving this problem. So for this method, I'm going to tell you, I'm going to use Venn diagram, right? Venn diagram. So, okay. So now, try the question. So there are 60 students in the sixth form, right? 60 students in the sixth form of a certain school. Mathematics is studied by 27 of them. Means number of mathematics taking mathematics course will be 27 of them, right? And biology or study biology, 27 of them study 27 of them. Mathematics is studied by 27 of them. Biology by 20. Biology by 20 of them, right? Biology and 22 students study neither mathematics nor biology. Means that mathematics or biology, neither means mathematics or biology also not study. They not study biology and mathematics. Okay. So this is the meaning here. Study neither two of these. Either they are mathematics or biology. They are not choosing either mathematics or biology. Another meaning here. So you read the question carefully. So, okay. Mathematics is studied by 27 of them, right? Mathematics is studied by 27 of them. So, 27 of them. Biology by 20, alright? Biology is 20. And 22 students study neither mathematics nor biology. Means that mathematics or biology also not study, right? Not study both of them. So total you have 22, right? 22 students study. So, alright. Then the question said, find the probability that a randomly selected student study both mathematics and biology, right? So for me, it will be easier for me to represent this question in a Venn diagram, okay, the information in a Venn diagram, because it just have two events only, right? The events that the student is taking mathematics, right, or the student is taking biology. So I drawing such that they are intersect because the student can take mathematics or biology, right? A student. So now we know that mathematics or biology not study both of these, right? It's outside, right? Outside. So I put a 22 here. The numbers of students that not study mathematics or biology means outside the set here, right? So it's 22, all right? And mathematics have 27, has 27. But don't forget, they study mathematics has 27 students, right? But maybe some of the students in the mathematics are study biology also, right? Maybe they study both subjects. So I just putting here as X here, right? X. So, and here we have 27 minus with X, right? Because total up this. If I take 27 minus X plus X, you will get 27. Total up mathematics, total number of students taking mathematics is 27, right? Definitely for this biology, right? They said taking biology, the student taking biology, maybe the student also can taking mathematics, right? So means 20 of them, I need to minus away the X, right? Because some of them also taking mathematics. They're taking two courses. Alright, so before we solving the question for part A, part B, part C, it's better for us to understand this diagram first, right? This Venn diagram. So mathematics total up, you have 27. This one, if you total up negative X plus X, you have 20 students, right? Then outside the Venn diagram, right? Outside the set M and the set B, there is 22. Because this is neither taking mathematics or biology, right? So, but you know that total up all the students must have how many students, right? You look at the question here. The question said there are 60 students in sixth form. Total we have 60 students. So 60 students means total up all this. The 22 that not taking mathematics or biology, or those who taking mathematics only, right? This is for those who taking mathematics only, and this one taking both subject, and also the one that taking biology only. Total up, it must be have 60 students, right? Must have 60 students. So then you calculate the value of x, right? Negative x plus x, you have 0, right? Negative x plus x, you have 0. Then you total up all the number here, right? Then for here, you total up, you will have 69, right? 69 negative x equals to 60. So we can find the value of x by bringing over there, and this 69 minus 60, we have 9, right? 9. So now I can redraw the Venn diagram, right? The Venn diagram. So the complete one will be, you know that this is 9, right? This is 9. So you know this is 9 students. 9 students taking both subjects, right? 27 minus 9, right? You have 18. 27 minus 9, you have 18. Right? You have 18. So 20 minus with 9, you have 11 students that taking taking biology only, right? Biology. If you total up this, all the number here, you are getting total of 60 students. Alright, so now you have all the information by using Venn diagram. Okay, this is the probability problem that you using Venn diagram will be helpful for you. Alright, will be helpful for you. So now find the probability that a randomly selected student, right? Find the probability that a randomly selected student study both mathematics and biology. Study both. This is the one that study both, right? Mathematics and biology. So alright, you have shown your calculation just now. So it means the probability of study mathematics and biology will be, you have 9, right? 9 out of total, right? 9 out of total 60. You have total of 60 students, right? So let's see what's the answer. 9 over 60. You will have 3 over 20, right? 3 over 20 or 15%, right? 0.15. The probability of 0.15. Alright, let's look at part B. Find the probability that a randomly selected mathematics student does not study biology. Find a probability that a randomly selected mathematics student, they already mentioned that it's a mathematics student and does not study biology. Means that the question has already telling you that, you see, find the probability that a randomly selected student does not study biology. Means it's a case, the conditional probability, because there's a probability that a randomly selected student does not study a randomly selected student, mathematics student. They already tell you that it's a mathematics student. It's a mathematics student that do not study biology. Do not study biology. This is the meaning here. I repeat again. Find the probability that a randomly selected mathematics student, means that from the mathematics student, I know it's from the mathematics student, which does not, the mathematics student does not study biology, right? Which is this part here, alright? This part here. So given, why I know this is given? Because I know that it is come from mathematics student. If you compare with part A, right? If you compare with part A, they say that find the probability that a randomly selected student, right? A randomly selected student means that it can be any student that taking biology, means from the 60, right? From the 60. But this question different. Find the probability that a randomly selected mathematics student. This is student, this is mathematics, it means that they come from mathematics. You know they come from mathematics. So it's a very easy way of doing this. You're just doing this. Mathematics total got how many? 18 plus with 9, right? 18 plus weight 9. Out of the 18 plus weight 9, then does not study biology. Then find that a selected mathematics student, right? That a randomly selected mathematics student, which is I know is 18 plus 9. The total is 18 plus 9. And student does not study biology. Does not study biology is 18, right? Out of here, you must choose from here, right? 18, right? It's 18 of them out of the 27, right? Let's calculate, which is 18 or 27, 2 over 3. You are getting 2 over 3. That's very important. Okay, you must understand. If let's say, if I say that find the probability that it's a biology student. It's a biology student who take mathematics. So you can using formula or you can read from the Venn diagram, right? The student, let's say I add another question. Find the probability that a randomly selected mathematics student and selected biology student must be biology student. Means come from the biology. You have 9 plus 11, right? 9 plus 11 who study mathematics. So means that given that it's a biology student, find the probability that a randomly selected biology student, right? For example, so from the biology student, you know that you have total of 20, right? Out of 2 of these, some were taking mathematics, some are not taking mathematics. So find those that taking mathematics. So it will be 9, right? 9 over with 20. Right? I modify the question. For example, if the question asking this way, means that find the probability that a randomly selected biology student, you know it's from biology student, that study mathematics is 9, right? 9 out of the 20. So I hope you understand this, okay? The meaning here. So, alright, let's look at part C. Alright, let's continue with the final question here. C. A student is selected at random. Determine whether the event study mathematics. The event study mathematics is statistically independent or is independent of event not study biology. Means that they want to determine whether these two events, is it independent or not? Statistically independent means this and this, right? So very simple. So you have to so I revise again. So if you want to know that if events A and B, right? If events A and B are independent, okay, are independent. So there are 2 ways of determining it. All right. First is the probability of A given B must be the same as the probability of A, right? And also, the probability of B given A must be the same as the probability of B. This is a first method, alright? A second method will be if you're able to prove that A intersect B is the same as the product of these two, right? Product of probability of A multiplied by probability of B, the value is the same, then they are independent. So, okay, for this method, I'm going to use the first method, alright? First method. So, very simple. You must prove that. So, I use what is given here, right? What is I already found here. Easier, right? I use what I found here. Because it's between B prime and M, right? B prime and M. So A and B. So now this is your A and B. So I can using this B prime given M, right? Is found to be 2 over 3, right? It's found to be 2 over 3. So if this is your A and this is your B, right? PA given B equals to 2 over 3. So I need to show that PA given B must be the same as PA, right? A, B, B, right? So means that I find the probability of B prime, right? Find the probability of B prime. If these two happen to have the same value, then we said that if they have the same value, we say that A and B are independent, or we say that this and this are independent, right? A very simple way of determine. So how to find probability of B prime? B prime means not taking biology, right? Not taking complement of B, not taking biology, will be 18 plus 22, right? 18 plus with 22 over with total of 60 students, right? If you're doing this, you will have 40, right? 40 over 60, which also giving you 2 over 3. Can you see that? They have the same value, right? They have the same value. As long as you're able to prove that PB prime given M is the same as PB prime. Alright, look at this definition here. Look at this concept here. If PA given B is the same as PA, or if PB given A is the same as PB, then we can say that they are independent. So this is already proof that, okay, we already proved that these two are the same. A very simple explanation. So yes, I can answer that. The events, okay, you can write down the events, mathematics, taking mathematics or study mathematics, and the events not study biology are statistically independent. Alright, statistically independent. So you can also try by using the second method here. So if you're interested, you can continue watching my video. Or you can stop here if you already accept this, right? Alright, okay, if you're interested, let's look at method 2 here. Alright, method 2 here. So they want to show that study mathematics and not study biology is independent, right? No, it determine whether they are independent or not. Alright, so very simple, you find the probability of M intersect B prime, right? Very easy. From here you can read. Taking mathematics but not biology is 18, right? Taking mathematics but not biology, right? This one is taking mathematics, biology, we don't want, right? B prime, we don't want those who taking biology. It's only mathematics, right? This means that this is the meaning that you're taking only biology, right? 18 over with 60, right? Let's calculate first. 18 over 60 will give you 18 over 60, which will give you 3 over 10, right? 3 over 10 or 0.3. So, okay, let's see. If you find the probability of mathematics, right? We're using this, right? Mathematics and not biology, not taking biology. So if you multiply these two probability, it's the same as this one, then you will already show that they are independent. So taking mathematics, we have 27, right? 27 out of 60, total up is 2. And not taking biology, right? Not taking biology, so means that not 11 and 9. Outside, right? B prime. Complement of B means outside. 18 plus 22, right? 22 over with 60. Okay, let's calculate. 27 over with 60. So you have 9 over with 20, right? 9 over 20. And 18 plus 22 over with 60. We have 2 over 3, right? 2 over 3. Alright, let's take this probability, multiply with this probability. Let's see. So we're taking mathematics, multiply with probability of not taking biology. Okay, multiply and the check, verify. Okay, 2 over 3. So 3, 9, right? 2, 10. So you will have 3 over 10, right? You are getting the same value now, right? You are getting the same value. This does not always have the same value. So when you multiply these two probability, it's the same as the probability of M intersect B prime. This is already show that this is equal, right? They are equal. So means that events A and B are independent, or events mathematics and not study biology are independent, right? Use the second way of proving. Alright, I think that's all for this question. Hope you deeply understand how to solve this problem.